Mrs. Stanley here. This is AP Calculus Lesson 3. We are looking at topic 1.5, determining limits using algebraic properties of limits. So I will let you read this paragraph. It says there will be times when you need to consider limits of functions symbolically, such as f of x, g of x, h of x. When you're giving combinations, compositions, and other modifications of these non-specific functions, there are some important properties of limits that will prove essential to these general function types. So basically, we're looking at some different properties that apply and how we can use them to help us simplify and do limits more easily. Here are the things that you must keep in mind. Let b and c be real numbers. N is a positive integer, and f and g are functions. Remember, as a function, that means you have a one-to-one relationship of the x and y. You pass the vertical line test. So here we go. Let's look at these. The constant rule, number 1, limit of x goes to c of k equals k. So this is, for example, let's say that the function is y equals 4. And when you graphed that on your x and y axis, it would just be a line at 4, right? It would make a straight line across. And so the limit would always be 4. So that's what this one is saying. Number 2, the identity rule. This is actually for y equals x. Okay? So the limit as x goes to c of x equals c. So if you think about it, again, with your x and y axis, let's say that you have the graph, it goes like this. And remember, the values are 0, 0, 1, 1, 2, 2, 3, 3. So y always equals x. That means that x equals c. Whatever the x is going to, that's going to be your limit. The coefficient rule. The limit as x goes to c of b times f of x equals b times the limit as x goes to c of f of x. So notice all that's happening is that this b in the function, or multiplying by the function, can be pulled out to the front and multiplied times the limit. So you can take the limit of the function and then multiply by the coefficient. Number 4, the sum or difference rule. So what this one says is that the limit as x goes to c of f of x plus g of x, or f of x minus g of x, is the same thing as adding the two limits. So you can take the limit of each function and then add those answers, or you can add the functions and then take the limit. It's generally easier to do the limits first and then add. You can do the exact same thing with the difference, okay? So the limit of the sum is the same thing as the sum of the limits. The limit of the difference is the same thing as the difference of the limits. Going to the product rule, this is multiplication. Same idea as the adding and subtracting. I can do the limit as x goes to c of f of x times g of x, or I can do the limit of f of x times the limit of g of x. So this one we could say the limit of a product is the product of the limits. The limit of a product is the product of the limits. The quotient rule. The limit of a quotient is the quotient of the limits. So similar situation. We can divide the two functions and then take the limit, or we can do the limit of f of x, do the limit of g of x, and then divide. The key one detail that's different is that g of x, the limit of g of x cannot equal 0. Let me make that highlight a little better. The limit of g of x cannot equal 0 because then we would have division by 0, and that's not allowed. The power rule. The limit as x goes to c of f of x to the nth power is the same thing as the limit as x goes to c of f of x all to the nth power. That one's harder to say out loud, but looking at the example, it does make sense, and you can figure out how to say that in a way that works for you to understand what you're meaning. Notice that n is rational. And then on number 8, the composite function rule. The limit as x goes to c of f of g of x is the same as f of the limit as x goes to c of g of x. So looking at this one, you can take the limit of the inside function. Notice that g of x is inside. Let me underline it here. And so we can take the limit of the inside function and then evaluate the outside function at the value of the limit. Don't worry, we're going to get some examples to practice this. The root rule. We've got the limit of an nth root of f of x. Okay, so we're taking the limit of the nth root of f of x. That is the same as the nth root of the limit of f of x. If the root on the right side exists, remember this is left, this is like you've got left and right, so this is the right side. If this limit exists, you can take the nth root of it after you found the limit. Again, these are just some shortcuts that help us get our answers more simply than if we had to do the functions as they're originally stated. So, being skilled at writing these rules in English will help you truly understand them. For example, the sum or difference rule can be stated as the limit of a sum is the sum of the limits. Same thing for difference. The limit of a difference is the difference of the limits. See, we're actually going to do this on Flipgrid. You'll see an assignment there. You're going to go in and post how you could read each of these in English. How could you say them out loud? So we'll come back to that in the Google Classroom assignment. Here are our examples. This is my suggestion to you. I'm going to work through these. Once you feel like you've got the hang of it, go ahead and start pausing the video and check your answer. And that will help the video to go faster for you, but also you'll know that you're getting the hang of it. Okay? So here we go. Looking at the instructions first. Use the properties of limits to find each of the following limits. If a limit does not exist, state why. Okay, looking at number 1, we've got the limit as x goes to 3 from the right of f of x plus g of x. So we've got a sum here. And I do want you to go ahead and get used to just writing out the property because that will help you to remember what the property is. So we're first just going to write it out. The limit as x goes to 3 from the right of f of x plus the limit as x goes to 3 from the right of g of x. And then we're looking at our graphs. On f of x, we're going to 3. Oh, positive 3 is over here, so we're up here. Coming from the right, so that's coming this way, the limit is 6. And then we're looking at g of x. 3 is right here. We're coming from the right, so we're going here, and that is 8. So we've got 6 plus 8 equals 14. That is our answer. Then we go to B. The limit as x goes to 5 of 3 times f of x minus 2 times g of x. So this one has two properties. It's a difference and we've got coefficients. So I'm going ahead to rewrite this. I can say 3 times the limit as x goes to 5 of f of x minus 2 times the limit as x goes to 5 of g of x. So I have split this into two different limits and I have moved the coefficients out front. So let me erase what I've already written on our graph so we don't get too much stuff. Let's look for 5. So on f at 5, we're right here, and that's a positive 2 from both directions. So this is going to be 3 times 2 minus 2 times, let's find the limit as x goes to 5 on g of x. So here's 5. So we're right here at 4. So I've got 2 times 4. So I have 3 times 2 minus 8 equals negative 2. That is my answer. So you can see that the arithmetic is fairly simple and straightforward. The problem is making sure that you've got your limit correct. That's why we are taking the time to go ahead and write it out, and I ask that you go ahead and do that. So on C, we've got the limit as x goes to negative 5 from the left of f of x minus g of x. So this is another difference problem. So I've got the limit as x goes to negative 5 from the left of f of x minus the limit as x goes to negative 5 from the left of g of x. So let's see what that equals. On f, look at negative 5 is over here. I'm coming from the left, so that's actually up here at positive 3. And then I've got g of x at negative 5. Here's negative 5. And I'm coming from the left, so I'm coming here, which is 4. So 3 minus 4 equals negative 1. This is my limit, right? Okay, continuing to letter D. The limit as x goes to negative 7 of 3 times f of x divided by g of x. We've got a quotient here, so I'm going to separate this out. 3 times the limit as x goes to negative 7 of f of x divided by the limit as x goes to negative 7 of g of x. So looking at that, we know we have the 3, so let's write that out. And we're looking at f going to negative 7. So negative 7 is right here. Let's erase my purple marks. If we're coming to negative 7 from both directions, perfect. This is a linear part right here, so it's just 3 times 4 divided by looking at g of x. Negative 7 is right here, so we are at positive 3. Yes. Actually, for some reason, I just noticed this one. I don't know why I wrote 4. This is negative 6, and we needed negative 7, so we should be up here at 5. So let me erase this out and put the 5. It should be 3 times 5 divided by 3, which we know would just leave us 5. So the limit there is 5. Okay, erasing my marks. Looking down at the next one, number 4, I'm going to first write it out and then we can go back to the graph. So looking at number 4, I've got the limit as x goes to 3 of 4 times the product of f of x times g of x. So that means I'm actually bringing the 4 out front. And I've got 4 times the limit as x goes to 3 of f of x times the limit as x goes to 3 of g of x. So I'm going to find both of those, take the product, and then multiply by 4, right? Because we moved the coefficient out front. So using the product rule, let's look at f of x as x goes to 3, and it is 6. So here we've got 6 times g of x as x goes to 3. Uh-oh, what do we notice? This one doesn't have a general limit. And it doesn't say as x goes to 3 just from the left or right. It has x goes to 3. That does not exist. Since it doesn't exist, we can say that the function does not exist. Okay, now going to letter f. The limit as x goes to negative 3 of f of x squared. Remember, what we're going to do on this one is that we are going to take the limit as x goes to negative 3 of f of x, and then we're going to square it. So we need the limit as f of x goes to negative 3, and that's right here at negative 6. So this is going to be negative 6 squared, which is 36. Coming down to g, the limit as x goes to 4 of the square root of 8 times g of x. Please remember that if you are figuring these out, go ahead and pause and then check your answer. So I'm going to do this one. It's got multiple parts, right? We've got the square root, which we can take the square root at the end. We'll move that out. We've got the coefficient of 8. And then we've got the limit as x goes to 4 of g of x. So notice that we've applied multiple properties here. I brought the coefficient outside the limit, but I also brought the square root out. Okay, so let's go ahead and work through that process. X goes to 4 of g of x. So here's the positive 4. The value is right here. The answer is 5. So I have the square root of 8 times 5, which is the square root of 40, which we know is 4 times 10. So that would be 2. Oh, that's wrong. 2 square root of 10. 4 times 10. 2 square root of 10. Okay, let's look at the next one. The limit as x goes to negative 3 of f of x plus g of x. This is just the sum, and so we're just going to separate this out and look at this. The limit as x goes to negative 3 of f of x plus the limit as x goes to negative 3 of g of x. So we come back up to the top. X goes to negative 3 for f of x. It's negative 6. Plus negative 3 for g of x. Oh, that's our vertical asymptote. So again, does not exist, which means the whole thing does not exist. So letter J, the limit as x goes to 6 of f of x over g of x. We're just going to separate this out. The limit as x goes to 6 of f of x divided by the limit as x goes to 6 of g of x. And then we work this out. So f of x, let's go back up here, and we're looking at x goes to 6. Positive 6 is right here. We get 0. So this one is 0 over the limit of 6 as x goes to 6 on g of x is positive 5. So now if 0 divided by 5, we know that's just 0, right? And then the last one on this section, the limit as x goes to negative 2 of f of g of x. So we're going to bring out f, and we're going to have the limit as x goes to negative 2 of g of x, and then we're going to evaluate f at that value. So I'm going to have f of, what is g of x as x goes to negative 2? Here's negative 2. We come down and find the point. It's right there. It looks like, oh no, it's a little bit higher. I went too low the first time. Let's erase my marks and double check. So we coming down, right here is where we connect. That's at negative 3. So I've got negative 3. F of negative 3, well, we come back up here. F of negative 3 is negative 6, so the answer is just negative 6. So notice what we did there. We took the limit as x goes to negative 2 of g of x, and then we evaluated what is f of negative 3. Okay, and the answer is negative 6. So let's go to the next section. Again, same thing. We're going to have a different type of examples here. But once you figure it out, please just start working ahead and check your answers. Okay? This video is going to be a bit long just because I'm working them all out, because I want you to have as many examples as you need. But don't feel like you need to sit and pause and watch each one and take your time. So here's the information. Find the limits of find the limits if the limit as x goes to c of f of x is 3. So the limit of f of x as x goes to c is 3. For g of x, it's negative 2. And for h of x, it's 4. I'm going to erase that highlight because we won't need it. But basically, they've already told us what each of the limits are. And so we're going to use this information. So let's look at letter A. The limit as x goes to c of the square root of 3 times h of x minus 2 times g of x. So again, multiple things that we can bring out here. So we're going to bring the square root out to do last. And inside, we're going to do the limits with the coefficients outside. So I'm going to have 3 times the limit as x goes to c of h of x minus 2 times the limit as x goes to c of g of x. I should have known I did not make this near long enough. So here we go. These are, you're going to find, are not too difficult. The limit as x goes to c of h of x, we already know is 4. So I'm going to have 3 times 4 minus 2 times g of x. We look up here again, we get negative 2. So what we're doing is we're just looking up here in the information on example 2, and we're just using the values they already gave us. So now we can simplify this. 3 times 4 is 12. And this is going to be plus 4. So we have the square root of 16, which we know the principal square root of 16 is 4. So that's our answer. Letter B. The limit as x goes to c of the product of f of x times 5 times g of x. So we're going to use our rules here. I've got the limit as x goes to c of f of x times 5 times the limit as x goes to c of g of x. So I brought out my coefficient, and instead of doing the product of the function, the limit of the products, I'm doing the product of the limits. So the limit as x goes to c of f of x, we already set up here, is 3 times 5 times the limit of g is negative 2. So I've got 3 times negative 10, which equals negative 30. And just so that if you're looking at that later, you know that says 3 times negative 10. Okay? So that was negative 30. The next one, we've got the limit as x goes to c of 7 minus g of x squared. So just to be clear, we're going to write this out completely. So I've got the limit as x goes to c of 7. We don't get a lot of these examples. Remember, this is the one for the constant rule, but it's good to have one here and there. Minus, this is a difference, the limit as x goes to c of g of x, and then we have that square. Remember, the whole thing is squared at the end. So we do the constant property. The limit as x goes to c of 7 is just 7. And then the limit of x as x goes to c of g of x, remember we have that up here at the top, it's -2. So minus -2, and this whole thing is squared. So I have 7 plus 2 is 9. 9 squared is 81. Okay? D, the limit as x goes to c. We got a big one here. We got a whole lot of parts to write out. So we're going to bring out our coefficients. We're going to separate the addition, separate the subtraction. So I'm going to have on top 2 times the limit as x goes to c of f of x plus 3 times the limit as x goes to c of h of x all over the limit as x goes to c of h of x minus the limit as x goes to c of g of x. All of this. So we can simplify this pretty quickly though, because f of x is 3. So on top we've got 2 times 3 plus 3 times h of x is 4 up there at the top, all over the limit of h of x is 4 minus the limit of g of x is -2. So simplifying, 2 times 3 is 6, 3 times 4 is 12. On the bottom, 4 plus 2 is 6. So I've got 18 divided by 6, which is 3. Okay. Coming down, keep going. The limit as x goes to c of h of x times the sum of f of x and 6. So here we're going to have to separate these out again. So I've got the limit as x goes to c of h of x times the sum. So I'm going to do the sum as x goes to c of f of x plus the limit as x goes to c of 6. And this is like a parenthesis. So for h of x, we said up at the top it's 4 times f of x is 3 plus, remember this is a constant, the limit as x goes to c of 6 is just 6. So I have 3 plus 6 is 9. 4 times 9 is 36. Hopefully you're getting the hang of this, and you probably like, goodness, do I have to write out these limits? It's really good practice to help you memorize the rules, the properties. The limit as x goes to c of f of x squared. So in this case, we've got the x squared, and then we have a quotient. The limit as x goes to c of f of x squared over 4 minus gx. So let's write that out. On top, we've got the limit as x goes to c of f of x, and we're going to square all of that over the limit as x goes to c of 4 minus the limit as x goes to c of g of x. So on top, what did we say f of x is? It's 3. So I'm going to do 3 squared. And on the bottom, I'm going to have 4 minus -2. Simplify that. I've got 9 over 4 plus 2 is 6. Simplify that. We get 3/2. So there's our answer for letter F. Now we're going to come down to example 3. Okay, for example 3, it's a very similar process. We've just got lots of parts. We have a product here, and then we have subtraction and addition. So we've got subtraction and addition with a product mixed in. So we basically have to kind of use our order of operations and all of these properties to rewrite this. So first, I've got the limit as x goes to c of 2 times f of x. So we bring out the coefficient, and we have the limit as x goes to c of f of x times the limit as x goes to c of g of x. So that right there is in one big giant parentheses or bracket, however you want to write it. Minus, we've got a cube root of f of x. So I'm going to do the cube root of the limit as x goes to c of f of x. So we just brought the cube root outside the limit. Plus 2 times the limit. Notice that's g of x is squared, but the 2 is not squared. So I've got to put my parentheses. 2 times the limit as x goes to c of g of x squared. So now I can plug in. Remember, we've got right here that f of x is 8 and g of x is negative 4. So we're going to use that information. So 2 times the limit of f of x as x goes to c is 8. Let me change these this notation. I'm going to write it like this. 2 times 8 times the limit of x as x goes to c of g of x is negative 4. So 2 times 8 times negative 4 minus the cube root of the limit as x goes to c of f of x. We got the cube root of 8. That's easy enough. Plus 2 times the limit as x goes to c of negative 4 squared. So let's simplify this down. 2 times 8 is 16 times negative 4 minus the cube root of 8 is 2 plus negative 4 squared is 16 times 2 is 32. 16 times negative 4 is negative 64. So we've got negative 64 minus 2 plus 32. So negative 66 plus 32 equals negative 34 is our final answer. And I don't like the way the box went around that. There we go. So there's our final answer for that one. Notice that we basically used our old basic order of operations and we applied all of these properties. Let's come down to example 4 now. Okay, on example 4, this is something that we actually haven't done yet, and it's going to be taught more directly in the next few lessons. So I'm going to put a little box around this. I want you to go ahead and do these two problems, but just keep in mind that this might seem a little bit rushed, but it's actually pretty simple, so I have full confidence that you'll be able to do it just fine. So what we're going to do is we're looking here, given f of x equals x cubed minus x squared plus 4x minus 1, and g of x equals negative 2x, find the limit as x goes to 2 of f of g of x. So the part that's different is we have these two functions and we have a limit as x goes to 2, and you might be thinking, well, wait, I'm not sure what to do, because in lesson 1 we did the thing where you like calculated, like we would start with like 1.9, 1.99, 1.999, and we would work our way to 2, like 2.01, 2.001, and so on. What we can actually do is just substitute. What we need to know that's important is that looking at a and b, both of the functions f of x and g of x are both continuous functions, right? And for a continuous function, we can say that f of c equals the limit as x goes to c of f of x. What do I mean by this? We can plug in the value for c. Notice right here, this is my c and this is my c. We can plug in the value for c into the function, and whatever the value we get, we know that it's actually the limit. So we're just going to use that information to solve this problem. So in A, using the properties of limits, we know that because this is a composition, limit as x goes to 2 of f of g of x, we can bring the f outside, and we've got the limit as x goes to 2 of g of x. Now, how can we get the limit as x goes to 2 of g of x? All we actually have to do is plug in, you need to do g of 2. So g of 2 is just negative 2 times 2. What do we get? Negative 4. So this equals f of negative 4. In order to get f of negative 4, what do we need to do? We plug it into f. So that's going to equal negative 4 cubed minus, I forgot my negative, minus negative 4 squared plus 4 times negative 4, minus 1. And since this is not a class that's all about multiplying out polynomials, I would be fine if you plugged this into your calculator and got your answer. I'll give you the information just in case. We've got negative 64 minus 16 minus 16 minus 1. And so the final answer is that f of negative 4 equals negative 97. That's going to be the answer to A. The limit as x goes to 2 of f of g of x equals negative 97. Okay? Same thing on B. We're given f of x and g of x. You'll notice they're exactly the same. But what's different is right here, g is on the outside and f is on the inside. So what we're going to have is that we've got, let me change my color. We've got that g of the limit as x goes to 2 of f of x. So we plug in this time for f of x first. We plug in the 2, right? So for f of 2, I've got 2 cubed minus 2 squared plus 4 times 2 minus 1. And again, you can use your calculator. It's no problem. The answer is 11. So now that I know f of 2 is 11, I'm going to do what is g of 11, and that equals negative 2 times 11, which is negative 22, and that's our answer. Now again, I apologize if you're like, wait, how did we know we can do that? We're going to actually go over that in future lessons, but since they were thrown in here and it's not too complicated, I wanted to show you. These are both continuous functions, and that made it where we can just plug in whatever the value is that we're looking for. Limit as x goes to 2, we can evaluate at 2 to get the answer. Okay, so moving on to example 5, this time we're using graphs. So just to be clear, the same suggestion applies here. I'll do the examples, but you're not required to sit here and watch me do it. Feel free to just pause the video, try it yourself, and then fast forward the video to check your answer, whatever you would like to do. Use the graphs of f of x and g of x below to find the limit. So we've got the limit as x goes to 3 of f of g of x. So what am I going to do? Well, first I'm going to bring out my f, and I have the limit as x goes to 3 of g of x. So I'm finding the value of f at the limit of x goes to 3 of g of x. So where is my g of x? Is over here on the right side, and I'm looking for x going to 3, which is right here. It's positive 1. So this is going to be f of 1. So then on function f, I look for positive 1, and it's negative 2. So the final answer is negative 2. Okay, looking at B, the limit as x goes to negative 1 of g of f of x. So I bring out the g, and we've got the limit as x goes to negative 1 of f of x. So I look at f, where's negative 1? Come down, it's at negative 6. So this is g of negative 6. Well, we look at g, find negative 6. Here's where we do run into a little problem that's a bit tricky. Notice that negative 6, would be out here. Negative 6 would be about here. So we can extrapolate this because look, this is just a linear line, right? And it's going over 1, down 2, over 1, down 2, over 1, down 2. So at negative 4, I'm down here at 3. So if I went over to negative 5, I'd go down from 3, I'd go down 4, 5, go over 1 more, I'd go down 6, 7. So the answer is going to be negative 7. You could have written this out as a function and plugged it in, and look at it here. If we went up 2 more, it'd be 5. So this is really 2x plus 5, y equals 2x plus 5. We could have evaluated that at negative 6, which we know would work. 2 times negative 6 is negative 12 plus I wrote 7 and it's supposed to be 5. I said 2x plus 5. I don't know why I wrote 7. Probably because I already knew the answer was negative 7. So anyway, that's one way to do that. All right, going to the next one. The limit as x goes to 1 of f of g of x. So I've got f on the outside, the limit as x goes to 1 of g of x. So we look at g of x, we find 1. Look what we have here. This does not exist. we run into another problem here. And this is a special rule for composite functions. So what we're going to need to do is actually consider this function from the left and the right, because there is no limit for g of x as x goes to 1 as far as a general limit. But what we have to do is we have to test it. So I'm going to make my space a little bit bigger so that I have more room to write. I'm going to pause the video to rewrite what I already have here smaller to not waste your time. Okay, now that I'm ready to continue, here's what we're going to do. We are going to consider this in two processes. So first, I'm changing my pen color, sorry. We're going to do the limit as x goes to 1 from the right of g of x. And then we're going to do the limit as x goes to 1 from the left of g of x and get those two values. Because we saw that they're not the same, right? So the limit as x goes to 1 from the right is coming to -3 from above. And it's important to note that it's going to -3 from above. What do I mean by above? Look at the y values. The y values coming from the right, the y values are higher than they are right here. Because this is -3, it's -2, -1, 0, 1, 2. So it's coming toward the -3 from above. Then we've got the limit as x goes to 1 from the left. Interestingly enough, this is also coming from above. It's going smaller in the y value as we approach -1. So the limit there is -1. As we approach 1 from above, it's -1. Again, we need to say from above because we're going to use that. Because now here's what's going to happen. I'm going to change my pen color again. And we're going to look at f for those two values, okay? So what we're going to look at is we have -3 and -1, both from above. So I am going to look at f, the limit as x goes to -1 from the above, which would be from the right, of f of x, and I'm going to look at the limit as x goes to -3 from the right of f of x. So what am I doing? Where did I get this information? This is my -3, this is my -1. From above, right is positive, so we're coming from the right now. So we're going to go back to our graph and look at f of x as x goes to -1 from the right. So I've got -1 right here. As x is coming from the right, it goes to -6. Okay? Then the same thing, limit as x goes to -3 from the right. From the right, it's coming this way. Here it is. It's still -6. If these two things match, which they do, then the answer actually works. So, therefore, actually, let me change my pen color again. So, therefore, the limit as x goes to 1 of f of g, oh, I forgot my other x, of f of g of x equals -6. And this is our answer. Okay? Okay, so we've got just one more. The limit as x goes to -3 of g of f of x. So we're going to separate this out. We're going to put our g outside. The limit as x goes to -3 of f of x. So we're going to do as x goes to -3 for f of x. I've got all this writing on our graphs. Let me remove this. So we're coming to -3, and we already said before actually that this is -6. So we have g of -6, which we actually have written right up here. Look, we already know it's -7. G of -6 is -7, and that is the last problem on this note section. Again, if C right over here was confusing, don't worry. we're going to get plenty of practice, and it was just sort of throwing in something in a strange example because it's like a special case. So don't worry if you felt like, ooh, I kind of get it, but that was a little fast. We'll get more practice. Okay, thank you so much.